computer and then share the screen. Let me see. So we have socket and then okay, let me see. I think I forget something. So okay. Thank you for give me the notice. So I forgot to record, but now I start. Okay. So this time you may hear about a little bit of crazy things, missing a little portion, but that's fine. But this time we have this kind of server architecture. So the client, the server side is the passive, right? It's passive, it's always on host, and it has a permanent IP address. This permanent is very important. You cannot change that IP address, otherwise the client cannot connect to it. And then if you have too much data, then you may have the data centers, or we call the cloud, for scaling. So you can store in the cloud. So this is the server side. Client side, it's a active socket. So this one is communicate with server. May not always connect. So it can have certain kind of disconnection, then connect it back. And it also can have a dynamic IP address. So you just, you don't need to worry too much about your IP address. So, but I need to know the server IP address. And then I do not need to communicate directly with each other. So if car want to tell with the server, then computer also talk with the server. So in these two examples, and between these two guys, you don't need to communicate with each other. Even if this guy want to communicate with the car or with the other device, but through, for example, through the chatting or Skype, through the Zoom, for example, it will connect with the server, and the server will transmit that data to the other guys. So it's not directly communicate between each other. Okay, so what is the good thing? The good thing for client and the server architecture is a client should be very easy, right? So client is lightweighted, so it's easy implement. So easy, right? So easy client or lightweight client, and it's more dynamic for the client. It can be during the communication, during the client server service, the client can go back and forth, so you can connect back and forth. It can have different IP address, it doesn't matter. And it just need to know the easy implementation, because it's just need to know what is the server IP address, what is server part to provide. So it's very easy for the client, and the client, you can make it very, very simple version. But what's the disadvantage is actually is at the server side. The server side is it should be always on, it should be permanent IP address. So the server side is more like a static one. Static. And the second thing is for the server side, another thing is this one is a heavy load. So heavy load, especially if you deal with a lot of customers, a lot of clients, then this one will be heavy load for the server. That's why we need architecture of the server. We need a cloud to store the data to reduce one server workload. So, but this one is still cause the problem because server is such important things in this architecture. Then we have a very famous problems there. If you are interested in research on this, on the server, client server architecture, and you want to do the research for the server, then this one is like a TCP. The congestion control is one of the 10 most important question. This one at the server, one of the most important question is how we share the load as well as do the migration between servers so that we can serve the customers as well as each server will not that high overloaded, will not overloaded. So this one is a question how we deal with client server architecture. Also, server has another problem is the security problem. Right, security problem these days is always one of the most important problem. Client usually, we definitely need a security for client because you have the user ID and the password maybe, but the security at the server side is more important than client side because the server will serve too many customers. And one of the famous security problem is called denial of service. So this one is attack the server. So denial of service, attack the server. So in this time, how do you protect your server? So this is another big issues. Okay, so this is client server. So we see that there's a lot of issues associated with the server because it gives the high priority to the server. So why we eliminate the server? Yes, we have another architecture. It's called peer-to-peer architecture. So peer-to-peer architecture is everyone can be a server, everyone can be a client, everyone can get the information and also provide the information. Everyone can search for the data, everyone can provide the data, everyone can communicate with each other, and there is no priority. So this is the peer-to-peer and the arbitrary and the systems, you do the directly communication. This one is architecture is, you can see that if you want to communicate, you can communicate each other. So you can also communicate like this or that. And this one, the good thing is there's no server, so you don't have the scalability problem. But actually, no. If you do pure peer-to-peer, definitely they assume that there's no scalability problem. But actually, we cannot do that pure peer-to-peer, so we still meet certain kind of scalability problem, especially when you want to search peers. Search peers is a kind of headache thing because you cannot connect all of them, so you need to create some arbitrary architecture. If you are interested in this peer-to-peer architecture, one thing is for the application, they have the BitTorrent as application. Also in our wireless communication, we have one thing is called ad hoc network. Ad hoc network is try to make your wireless communication without the base station. So you deliver the message through the peers, through your peers. So this one is we call the ad hoc network. So sometimes you may see the ad hoc at your wireless connection. So this ad hoc connection is what we use for some place, for example, like within a mountain area, there's a hard to build the base station, but you still want to do some communication with a group of people, then you can do the ad hoc network and let one computer or one guy connect to the satellite and communicate to the other guys. So communicate to the outside. So this one is ad hoc network. Okay, so far so good. Any question? There's no question, then I will move forward. Oh, this architecture. And now we will move to the next topic is kind of circuit programming. Before the circuit programming, we will do the process communication. So process communication, process is the programming running within a host. Actually, you can treat the process like a running program, and the program is not a running process. Okay, so program, when you code it, not click the running button, this one is the program. When you click the running button, it's running your system, then this one is called a process. That's why, so we can, two processes can communicate using two ways. One way is they can share memory. If they are at the same host or same computer, they can share memory. So this one is another way to do is called the inter-process communication, IPC. This one we will learn in operating system. Some guys have already learned. So inter-process communication, we have one way is we create the Unix pipe, but the most common way we do is through the socket programming. So socket is the way we do, and socket programming for this process communication, we have the client process and the server process, and you can see that this one is the not peer-to-peer, it's the client server style. So client process will process that initiated communication, and the server process is the process that waited to be contacted. So this one, server process like a bank teller, and the client service like the client, right? So this one is what we do, the process communicating. And one of the famous one is the socket programming for the inter-process communication. So the socket programming, let me see. Okay, so this one. Okay, for the socket programming, I will introduce the Java socket programming. If you are interested, you can also do the C socket programming. It will give you the clear picture. So last time I showed the example here, I just do the briefly summary for the socket programming, and maybe something I'm missing in the example, but it will be it will show here. I will not show the UDP socket, but just using the TCP socket. So if you like to the UDP, I will post the slides so you can look at the UTP connection. So the Java socket programming, we have, if you want to do the Java socket, you should include the java.net. So this one is you should be import this packet so that you can use this one. And inside this packet, usually you have this 5 classes. We will use these 5 classes. The first one is actually the internet addresses. So this is address. So internet address. So internet address can be IP address. It can be later, if you have the DNS already implemented, then you can use the web address. So like 3w.hpu.edu. So it will convert to IP address. And then the next one is for the TCP. We have 2 sockets. One is called socket. Actually, this one is the client socket. This one is the client socket. And this one, the server socket, right? It's very easy. So this is for TCP. And of course, for UDP, you can have a datagram socket or datagram packet. So for the UDP, so TCP, here I will introduce is the TCP style. So, okay, so now we look at the first three classes. The first one is the internet address class. So you can give me the host, give me the string. So, and I can get the internet address. So for example, you can give me the internet address X. So through the get by name, give me the name. Okay, that's fine. Or you get all by name or get a local host. So the local host name. Okay, so you can give. So this one is quite straightforward. So you give me the host name, and then I can convert to the internet address. It's still a string, so but it's like the internet address type of objects. Okay, and the socket programming, and we have the client socket and the socket returned by accept. So this one is the client socket. And we have the active socket is the client socket. And another one is passive sockets supported by different class. One is the server socket, and UDP socket is supported by datagram socket. So Java TCP socket, we first look at the client socket. We can have the socket give the host name and give the port number. So host name, if you know the IP address, you can do is directly put the IP address in the double column in here. So for example, 10.0.0.0.1. So this can be the host name. Directly use the IP address, or you can use 3w.hpu.edu as the host name if you want to connect to the web server. And the port is TCP port, right? So this one is when you deal with when you connect to the passive socket, to the server socket, then you can use input stream and output stream to read and write. So input stream, output stream to read and write through the socket. And for the server socket, you only need to give is the port number, and then it will listen to the socket, to the channel, and when the client socket send out the connection request, it will accept it. When it accepts, it will return the connection, so the client socket. So it will return the client socket. So this is the whole thing, the socket. So at the beginning, I will create the welcome socket and listen to the channel. This is the first step. And the second step, when the client creates the client socket, it will connect to the welcome socket, and it will do the three-way handshake. And when the server accepts the connection, it will create the client socket. So this one is still the client socket. And this client socket type, this client socket type is active socket. And this one will do the communication with the client socket at the client side. So this is, I call it a connection socket. Okay, so you have the client socket at the client side. Server side, you will create two sockets. One is a welcome socket, is passive, listen to the channel. When it accepts the connection from the client, it will create the connection socket, which is the active socket. So you can do the byte reading and writing to this socket. Okay, so the socket, this is the constructor we use quite often is here. You can also put the internet address, the server here. So for the socket, so it's the same thing. You can get the internet address, get the input stream, get output stream for reading and writing. So this is similar to the java.io, so I will not explain too much. So I just list here, so it's not too much. But for the server socket, the easiest one, you just provide the port. And or you may have the log files associated with the server so that later you can look at which one is address, which one make a connection to me. So you can do the backlog. And then you can also have the binary address associated when you create the server. So you have the permanent IP. It's not, you don't want to use IP. If you don't provide, it's your own server IP, right? So your own address, then you can do it by the IP address. And then the server socket also provide the accept. So when you accept the other guy, the connection, then you create, your return type will be the socket, right? So you create a socket. So, and when you finish, you do the close part. Any question? I hear some guys talking. Okay, if you have question, please type in the chat part. Okay, so let us see the whole procedure for this client-server socket interaction. So you will first create a server socket. Let welcome socket equal to the server socket. You create the server socket. So then when you create this one, actually it will listen to the channel. Wait for incoming connection. So when it's the client socket create, so when the client socket created and connect to it, when it's connect to it through the TCP connection, then the server side will accept it. Okay, if there's no problem, it will accept it. And then, so when you accept, then this two, the client can send out the data and the server side can read from the connection socket. So the welcome socket will not use after it accepts the connection. It will, in here, since we don't do multi-threads, so this welcome socket will be blocked. If you do multi-threads, then welcome socket can still listen to the socket, listen to the channel and wait for the other connection, but you will create multiple threads. This one we will discuss in the operating systems. Don't worry too much at this time. And then it will write to the client and read, reply the client. So this tool is actually you can treat this pair like the file reading and writing. The only difference between file reading and writing is file reading and writing is write to or read from the certain file. Here, you can treat like this is, I create the channel of pipeline for you to read and write, for the both sides to read and write. And then when the client socket close the sockets and the server side close the socket, then the welcome socket will work again. It's not blocked in the process. So it will listen to the channel again and wait for the next connection. So it looks like you can treat like the bank teller, right? The bank teller. You first create the bank teller, and then when the customer comes, and then the bank teller will set up the connection with that customer, and then in the middle, this one is the service from service bank teller and the customer, between bank teller and the customer. And when the finish, then the bank teller go back and wait for the next customer. So this one is exactly the same as this example. Okay, several socket functions. You can create a socket. This time, we don't use bind, but you can. So the bind the local IP address and the port number if you put the bind there. This one is required in C, but Java will do it by default. If you don't put bind in for the server socket, it will. If you don't bind it, the Java socket will do it by default. You don't need to worry too much. There's no need to explicitly show bind. So this one you don't need for Java. But if you do the C++ or you do the C, then you should bind the socket with the server. So you should bind it. And then the server socket will listen to the channel. So this one in Java, I don't need to do it directly, explicitly. Because the Java, when you create the server socket, after it's created correctly, it will listen to the channel directly. So this two you don't need for Java. But if you do, why I list here, because if you do the C language or C++, you need this too. Okay, explicitly show. And then you don't need a connection. And then you just need to do the accept new connection, and then you can read and write. And when you finish reading and writing, you tear down the connection, you just need to close the socket. So here, the most important thing you will use in your programming is one is socket, one is accept. You should be able to read and write. Write is write data to a socket, and read is read the data from the socket, and then you should be able to do the close. So when you finish the socket connection, you should close. You should tear down. Why I should tear down? Because if you don't do here, then the welcome socket here, it will be blocked, right? So it will be blocked if you don't close the previous, then you cannot accept the next customer. Right, so this one, you definitely need to close your socket. So far, so good? Okay, let us go back to our socket programming. I'll go back to our, okay, one thing. This slide is on the Blackboard, so you can double check. I will post on the Blackboard. Associated with your next homework. So your last homework will be the socket programming. So these slides will be there. Okay, so we go back to we finish our socket introduction. I think the socket is here. So now the address processing, I will skip it. Application layers. So now we will look at what is the application layer protocol need to define. What is the service it wants the lower layer to provide. as well as the service required. So the first one is the protocol need to define the types of the message exchanged. So this one is the, for example, if you deal with HTTP web server, so you should request and the response. And also the syntax, so what is the number associated? For example, you may, when you do the web browser, so you type in some website, it will give you some 404, something like that. Then hosted not exist, something like that, 404. So you will see 404, something, some types of that one. Then you should define what the meaning for that one. And then you should also give the meaning for that information in the field. For example, 404, you should give me the information, what is the real meaning. And the rules for when and how processes send and respond to the message. So this one is application layer need to define. So types of message, message syntax, message semantics, and the rules for when and how processes send and respond for the certain message. So this time when we deal with application layer, every data we will not say packet, or I will not say segment. It will say here is called a message. Okay, so the message can be different size. Okay, the size can be unlimited. There's no limitation setting on the message size. It's not like your TCP or IP. You have certain kind of packet size or maximum segment size. Here, you don't need to worry too much about it. It's in the lower layer. They will separate. But we have certain kind of protocols, and which is defined in IFCs, so that you can do the interoperation. You can do the interoperation. So like HTTP, SMTP. So every guys, if you do the web browser or web server, or you want to do the mail server, you should follow the protocols. This protocols is already open to the public. So IFCs. So everyone should follow this. Otherwise, you cannot communicate with others. But we still have some private or something is held by the company. So like a Skype is not a common protocol. And then this is for the application layer protocol need to define. But then also you should request what kind of transport layer need to support. For example, some applications require transport layer to support 100% reliability. For example, you do the file transfer, you do the web transactions, you need to have this 100% reliable. Others may not require this reliability. So for example, your audio and the video do not need to guarantee 100% reliable data transfer. And the other one will look at the timing. So timing includes the ordering as well as the delay. So for example, I have the voice over IP or interactive games, then the low delay should be very, very important, right? So timing. And some applications require throughput. Those throughput, for example, multimedia, like the YouTube, you should have a minimum amount of throughput that is in fact should be considered. Otherwise, the multimedia will get stuck. So this one is the throughput requirement, but sometimes they don't want to get the throughput too much. For example, your email. So the email systems, you require 100% reliable data transfer, but you don't need to worry too much about the throughput because your email is not a big chunk. So a little bit of delay is no problem. A little bit of small throughput, or sometimes a big throughput, small throughput doesn't matter too much. So this one is a kind of transport service application need to consider. Then also the last one, security definitely. So actually, sometimes the application layer will classify the requirement for the transport layer like this. So different applications, do you allow the data loss? Means reliability. So do you want 100% reliable data transfer, or you can tolerate a certain kind of loss? And then the throughput is usually we base on the bandwidth. So for the throughput, so sometimes you need a certain throughput of the bandwidth. Sometimes you don't. Others is time sensitive. Time sensitive is looks like the delay. So how much delay you can tolerate. If you cannot tolerate the time, the delay, then it's called time sensitive. But sometimes we call time sensitive is also means how much the biggest delay you can tolerate. So, or if you don't set this biggest time you can tolerate, then it means that you can do the delay tolerance. Right, so this one I collect a certain, this slides collect a certain kind of applications, and within these three performance, so three requirements. So data loss, so sometimes we call it reliability. Oh, we have the throughput. We sometimes is called the guaranteed bandwidth, BW. So do you guarantee certain bandwidth or not? And time sensitive, sometimes we call it delay. So do you also, you may hear about the word to say, okay, delay tolerant or delay not delay tolerant applications. Okay, so reliability, bandwidth, and delay. Okay, we look at the file transfer. Reliability required is very high. You cannot do any data loss because your file will be corrupt if you miss some data block. So this one is reliability is very high, but they don't need to worry about the bandwidth as well as the delay. So there's no bandwidth, no delay requirement, but it's definitely require reliability. But another thing is, for example, the real-time audio and the video, the reliability is not that high. So you can have some loss tolerant, but the bandwidth you should guarantee. So for audio, around the maximum 1 megabit per second. For video, maximum is 5 megabit per second. And the delay, you should also guarantee. So it's time sensitive or it's not a delay tolerant. So this means it's only about the time, it can only about hundreds of milliseconds. So this one is very headache. So this one is not a delay tolerant. Oh, this is a too extreme case. So that's why in the RFC, it will suggest you what kind of transport layer protocol you will use. So email, for example, file transfer, you will use TCP because you want reliability, right? But for the streaming multimedia, you can use TCP. You may also use UDP. You can choose UDP. Why? Because it's not a reliability. It can do the loss tolerant, but the bandwidth and the delay may be, you should consider. TCP may need a retransmission, so it will do certain kind of delay too much. So it will not acceptable by the video, especially for the video. But this one, for the UDP part, usually for the streaming multimedia, if you use UDP, you will need the lower layer like the IP layer or the data link layer to reserve. So the IP layer to do the reservation. So you will do bandwidth reservation so that it will guarantee the performance of the delay as well as the bandwidth. Okay, so but this is another story. So, okay. Any question? If there's no question, then I will stop at here.